Okay guys, welcome back. We are going to be going over how many times greater. This is still in our scientific notation unit. I have 8 examples that we are going to go through today. Just a quick reminder that you cannot use calculators for this standard, so you need to make sure you are practicing adding, subtracting, multiplying, and dividing with decimals. Have that fresh in your mind. I'm going to try and zoom in a little bit so it's easier for us to see the problems. For our first example, it says the largest iceberg to split off from the Ross ice shelf weighed 4 trillion tons. There's 2 parts to this problem. First, we need to write the weight of the iceberg in scientific notation. That's a lot of zeros. We want to write it in scientific notation, and we know how to do that. We are going to follow LARS. So remember, our decimal is all the way over here. To convert this to scientific notation, we need to move it to the left and count how many places we have to move it until we get a number greater than 1 and less than 10. So I'm going to start moving that decimal point over to the left until I get a number greater than 1 and less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm stopping right here in between this 4 and this 0 because that gives me 4.0. 4.0 is greater than 1 and less than 10. So this is my coefficient, 4.0, or we could just write it as 4 times 10 to the 12th power. We had to move that decimal 12 times. So we did part A. Now we need to do part B. It says, write a number in scientific notation that is 10 times greater than the weight of the iceberg. So it's telling us it needs to be 10 times greater than this weight right here. So I'm just going to use multiplication to figure that out. I'm going to multiply my coefficient by 10 times. So 10 times 4. 4 times 0, 0. 4 times 1 is 4. So now we can rewrite our number in scientific notation with our new coefficient that is 4 times greater. This is 4 times greater. So we have 40 times 10 to the 12th power. Now we're not done though. This number is not in proper scientific notation. Remember, in order for a number to be in proper scientific notation, our coefficient here needs to be a number greater than 1 but less than 10. This number is greater than 10. So we need to make this number greater than 1 but less than 10. And we're going to do that by moving the decimal. So 40, if we were writing this as money, our decimal point would be right over here. We need to move that decimal till we get a number greater than 1 and less than 10. So I'm going to move it to the left 1 time. Now I have 4.0. That number is greater than 1 and it's less than 10. So our new coefficient is 4.0 times 10. Now remember LARS. LARS is left, add, right, subtract. We moved the decimal point to the left 1 place. We moved it left, so we need to add 1 to our exponent. So 12 plus 1 is 13. This is our answer. All right, sliding on down to number 2. Willie Day and his twin brother Wally Day combined to hit 8 times 10 to the 2nd power home runs during their 20-year baseball career. The Way brothers, Bert and Kurt, hit 5 times the number of home runs hit by the Day brothers. write the number of home runs and write the number of Way Brother home runs in scientific notation. So there was a lot of information in there. Like I always said in class, it's really important to go back and reread word problems to make sure that we understand the information given. So first, we're talking about Willie Day and his twin brother Wally Day, and it's telling us how many home runs they hit during their 20-year baseball career. This is how many home runs they hit. Then it tells us the Way brothers, Bert and Kurt, hit 5 times the number of home runs. So that's another important piece of information, 5 times the number of home runs. We need to write the number of Way brother home runs in scientific notation. So we need to figure out if they hit 5 times this amount, how many home runs did they hit? Again, it's telling us 5 times this amount, so we're going to use multiplication to figure this out. We are just going to take our coefficient here and multiply it by 5. 8 times 5. 8 times 5 is 40. So our new coefficient is 40 times 10 to the second power. Now again, it told us to write this in scientific notation. This is not in proper scientific notation. Looking at our coefficient, we see that this number is greater than 10. It cannot be greater than 10. It needs to be greater than 1 and less than 10. So this is where we have to move our decimal to make a number greater than 1 but less than 10. Our decimal point is right here. We need to move it to the left 1 place. By moving it to the left 1 place, we now have 4.0. And remember Lars. So Lars is if we move the decimal left, we have to add to the exponent. If we move the decimal to the right, we have to subtract from the exponent. We moved it to the left 1 place, so we need to add 1 to our exponent. 2 plus 1 is 3. So this right here is our answer. That's how many home runs they hit. Number 3. One type of beetle is known as the Hercules beetle. It weighs 1 times 10 to the second power grams. The beetle can carry close to 8.5 times 10 to the fourth power grams. This is approximately how many times its own weight in grams. Express your answer in standard form. So we need to figure out how many times its own weight in grams can it carry. And we need to make sure we write our answer in standard form. So in order to figure this out, we're given 2 numbers in scientific notation. We need to divide to figure this out. It's asking us how many times its own weight in grams can it carry. How many times its own weight. So we know that the beetle can carry 8.5 times 10 to the fourth power grams. We need to take that number and we need it to divide it by how much the beetle weighs. Now, when dividing numbers in scientific notation, it's not as intimidating as it looks. First, we are going to divide our coefficients here. So when dividing our coefficients, I'm going to set up my division problem. It's 8.5 divided by 1. So this right here is our divisor. So when we're setting it up, we set it up like this. Now, when we look at our divisor, we see it's already a whole number, so we don't need to move our decimal at all. Our decimal is going to stay right up here. 1 can go into 8 times. 8 times 1 is 8. We subtract. We'll bring down our other number. 1 can go into 5 times. So this is our coefficient. Now we need to divide our powers of 10. So when dividing with exponents, this is where we have to remember that rule. When dividing with exponents, we subtract. 4 minus 2 is 2. So our power of 10, we have 10 to the second power. Now we're not done yet. It tells us to express our answer in standard form. So we need to take our number in scientific notation and write it in standard form. We already learned how to do this. We see that we have a positive exponent, which means this number is going to get bigger. Our coefficient will get bigger. And that 2 tells us how many times to move our decimal. When it's positive, we need to move it to the right. And it's a 2, so we need to move this decimal to the right 2 times. So I'm going to go ahead and do that. I'm going to do it off to the side over here. And I'm going to move it to the right 2 times. So the beetle can carry 850 times its own weight. That's a lot. Go ahead and box my answer in. And we're done with that problem. Right, sliding on down to number 4. The population of Kentucky in 2011 was about 4 times 10 to the 6th power. The population of Texas is about 5 times greater. Write the population of Texas in scientific notation. So this time we get to write that population in scientific notation. To figure out the population of Texas, it tells us it is 5 times greater. So it's telling us how many times greater. We are going to multiply to figure this out. We are going to multiply our coefficient by 5. 4 times 5 is 20. So this is our new coefficient times 10 to the 6th power. Now we're almost done. We're not quite there yet. This is in scientific notation, but it's not in proper scientific notation because our coefficient here is greater than 10. So we need to move our decimal point to the left 1 time to get a number between 1 and 10. We moved it to the left 1 time. Remember, Lars, if we move it to the left, we have to add to our exponent. We moved it to the left 1 time, so we're going to add 1 to our exponent. So now we have 2.0 times 10 to the power of 7. So this is the approximate population of Texas. It told us to keep it in scientific notation, so we kept it in scientific notation. Halfway done, guys. A newborn baby was about 2.6 times 10 to the 10th power cells. Has about 2.6 times 10 to the 10th power cells. An adult has about 4.94 times 10 to the 13th power cells. How many times as many cells does an adult have than a newborn? An adult have than a newborn. And it tells us to write our answer in scientific notation. So we're trying to figure out how many times more. So this is where we need to divide. We're given 2 numbers in scientific notation, and we're figuring out how many times more. Now, in order to figure out how to set this up, it's important to read the problem. It's asking how many times as many cells does an adult have than a newborn. So the adult goes on top, newborn goes on the bottom. So adult cells is 4.94 times 10 to the 13th power. That's our numerator. And the baby cells goes in the denominator. Now again, we're just going to break this down. First, we are going to divide our coefficients. So we're going to set up a division problem, doing some long division. 4.94 divided by, remember fraction part means division, 2.6. So 2.6 is our divisor. Now we need to make our divisor a whole number, so we need to move our decimal to the right one time. We moved it to the right one time, so we need to do the same thing here. Moved it to the right one time, and that tells us where our decimal is going to be in our answer. Now we don't have to worry about that decimal anymore. We can just start dividing. 26 goes into 49 two times, or one time. 26 goes into 40 times. 26 goes into 49 one time. 1 times 26 is 26. We subtract. We get 23. 26 can't go into 23, so we need to bring down our 4. 26 can go into 234. It can actually go into it 9 times. Can do a little bit of guessing and checking or repeated addition. 9 times 26 is 234 with 0 left over. So our new coefficient is 1.9 times, now we need to figure out our power of 10. So we're going to divide our powers of 10. When dividing with exponents, we have to subtract. 13 minus 10 is 3. And it tells us to write our answer in scientific notation. So this is our answer. This is about how many more cells an adult has than a newborn. The average weight of a blue whale is 4 times 10 to the 5th power pounds. The average weight of an elephant is 1 times 10 to the 4th power pounds. Approximately how many times heavier is a blue whale than an elephant in pounds? So we are given the whale and the elephant, and it wants us to figure out how many times heavier. So we need to figure that out. When it asks us that, we know we need to divide, given two numbers in scientific notation. Now remember, you can look at the question to figure out how to set this up. It says how many times heavier is the blue whale than the elephant. So blue whale goes on in the numerator, elephant goes in the denominator. Now we're going to break this apart. First, we're going to divide our coefficients. 4 divided by 1. 4 divided by 1 is 4. We could also do a little long division. 4 divided by 1. 1 goes into 4 times. So that is our new coefficient. Then when we look at our powers of 10, we are dividing, so we need to follow that division rule with exponents. When dividing exponents, you subtract 5 minus 4 is 1. So this is approximately how many times heavier a blue whale is than an elephant. We could also write this in standard form. It doesn't tell us how to write it, so let's go ahead and write it both ways. So our answer could be expressed in scientific notation, or it could be expressed in standard form. So we can convert this to standard form. It's a positive exponent, so we know we need to move our decimal over to the right one place. So our decimal is here. If we move it to the right one place, that would be 40. So 40 times. The blue whale weighs approximately 40 times more than an elephant. A concert sold 1.4 times 10 to the third power tickets at the gate. Online sales were 40 times greater. How many tickets were sold online? So it's already telling us how many times greater. So we need to multiply our coefficient by that number. We are going to multiply 1.4 times 40. 0 times 4 is 0. 0 times 1 is 0. Hold our place value there. Now we're going to multiply tens place. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 more is 5. Going to add these numbers together. Then our very last step is to figure out where does that decimal go. We just need to count the place values. Decimal is to the left one place, so we need to move it to the left one place. So now we have 56 times 10 to the third power. Now it's asking us how many tickets were sold online. It didn't say whether we needed to express this in scientific notation or in standard form, so we are just going to go ahead and do both. So this is not in proper scientific notation. We need to make our coefficient between 1 and 10. So I'm going to move the decimal to the left one place. Now I have a number that's greater than 1 and less than 10. I moved it to the left one place. So remember Lars, we move it to the left. We have to add to our exponent, plus 1. So times 10 to the fourth power. That's our answer in scientific notation. We could also write this in standard form. I can convert my number from scientific notation to standard form by looking at my exponent. I need to move my decimal to the right 4 times. 1, 2, 3, 4. Positive 4, so we know we're going to get a big number. I can rewrite this so it's easier to read. So they sold 56,000 tickets online. Tickets online. So this could be our answer expressed in scientific notation, or this could be our answer expressed in standard form. All right, last problem, guys. We made it. We are almost done. A baby elephant weighs 1.5 times 10 to the second power pounds. If the mother weighs 1.2 times 10 to the fourth power pounds, how many times heavier is the mother elephant than the baby elephant? So this is the baby elephant's weight. This is the mother elephant's weight, and it's asking us how many times heavier. So when we have to figure out how many times heavier, that's when we have to divide. And we can look at our question to figure out which number goes in the numerator and which number goes in the denominator. It says how many times heavier is the mother than the baby. So the mother's weight needs to go on top. 1.2 times 10 to the fourth power divided by 1.5 times 10 to the second power. Okay, let's break this down. Go ahead and divide the coefficients. You should be trying to do some of these problems on your own. Hopefully you'll go back and watch the video again and try and do some on your own. You can pause it now and try this one on your own. We're dividing our coefficients. So I need to set this up. It is 1.2 divided by 1.5. We need to make our divisor a whole number. So I need to move my decimal to the right one time. So now it's not 1.5, it's 15. If I move the decimal one time here, I have to do the same thing here. And that tells me where my decimal is going to go in my answer. Okay. 15 cannot go into 1, so we put a 0 there. 15 cannot go into 12, so we have to put a 0 there. Now, we don't have anything left. We need to add a 0 here. Can 15 go into 120? Yes, it can. How many times can it go into 120? Well, it can go 8 times. 8 times 15 is 120. We're going to subtract. And this is our new coefficient. 0.8 times. Now we need to divide our powers of 10. Following that exponent rule, when we divide, we subtract our exponents. 4 minus 2 is 2. Now we're going to write our answer in both scientific notation and standard form. This is not in proper scientific notation. Our coefficient is less than 1. It cannot be less than 1. It needs to be greater than 1 or less than 10. So, in order to figure that out, we need to move our decimal to the right one place. So remember Lars. If we're moving our decimal to the right, then we have to subtract from our exponent. We moved it to the right one place, so we need to subtract 1 from our exponent. So we rewrite this. We now have 8 times 10 to the first power. So this is our answer in scientific notation. We want to also write our answer in standard form. Positive exponent means big number. We're going to move our decimal to the right one place to get a bigger number here. Decimal is currently right here. We're going to move it to the right one place. So if it's here, I'm moving it to the right one place. Fill in my 0. So when we convert this number from scientific notation to standard form, the answer is 80 times. All right, I highly encourage you to go back, watch this again, try a couple problems on your own. You don't have to watch the whole thing again. Just do the ones that were tripping you up that you want to try on your own. I'm going to post a picture of these notes also to the webpage. Miss you guys. Have a good rest of the day. Bye.